Okay, we've now done these three questions. Let's move on to the fourth one. I've already copy pasted over here to save some time, and I also have the instructions again. So we're asked to prove whether or not it's regular. If it's regular, make a DFA/NFA for it. If it's not regular, use a pumping lemma. Let's first go over what the language actually is. It's all strings over alphabet A, B, where the string starts with some number of A's and ends with a single B. So n greater than or equal to 0. So just some number of A's, one B at the end. So this would be in the language, because we can have 0 A's. This would not be in the language, because we can't have 2 B's at the end. This would not be in the language, because we can't end with a B. And this would be in the language, because we have some number of A's followed by a B. So the first thing to think about is whether or not we would be able to make a DFA for this language. And the answer to that question is yes, you can, because you don't need an infinite amount of states. All you need to check is that the string starts with some number of A's and ends with a B. So let's go over a DFA, like an example DFA for this language. So we'd have a start state. Okay. So this state represents that we've seen nothing so far. So when we read in a B, what do we want to do? So imagine we see a B. Well, we want to go to an accept state, right? Because starting with just a B is allowed. Like if we have just one B, that's okay. So we go to an accept state. So this state will represent that we've ended off the string with a B. So if we're reading a B and we're in this accept state, and then we see other characters. So the string is something like this, or like maybe this. We don't want to accept this, so we go to a trash state. And if we're in this trash state, we stay there forever because there's no way to get to an acceptance. Okay, so we've gone over the case where we started with the B. Let's go over the case where we start with an A. If we start with an A, then we allow to see any amount of A's after that, and the only thing we need to make sure is that we end with a B. So we allow us to see any amount of A's, we just go through all the A's, and then if we see a B, then we want to check if it's the last B in the language, in the string. So we go to the same state as before. So if you see a B, you go here, then if there's anything after that B, we reject. So this is what a DFA would look for this language, look like for this language. So for instance, if we had string A, B, 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 what would happen is that you'd read an A from the start state, you'd go to QA, then you'd see a B, you go to the accept state, which is over here, then you would see another B, and so you go to the trash state, and then you stay there. So this would be rejected as expected. Let's look at just B. Read in B, go to accept state. And so as expected, we accept it. Then let's see this one. B. We want this to be accepted, right? Let's see if that happens. So we read in A, we go to QA, then we loop 2 times, and we read in a B, and we go to accept. And as expected, we accept, which is what we wanted. So the DFA behaves as we want. It should accept the strings in this language. So therefore, we've constructed a DFA that recognizes language, and so it is regular. And the pumping lemma would not be able to be used for this. You can't prove it's not regular, and so this would waste your time. So again, make sure that you think about whether or not a DFA would be possible for the language before you move on to pumping lemma.